Welcome to the Deep Dive, where we take a stack of information and really extract the crucial insights just for you.
Mm-hmm.
You got in touch wanting to understand something that, well, it feels like it's ripped straight from a sci-fi novel, geoengineering.
Right.
Specifically, you were curious about the UK's recent move into outdoor experiments. Okay, let's unpack this intriguing development.
Exactly. And what's happening in the UK is significant. So your curiosity, our listener, has led us to dig into a recent piece in The Guardian, but also, importantly, detailed info from the UK government agency leading this charge, the Advanced Research and Invention Agency, or ARA.
ARA, okay.
So our goal today is really to get a sharp understanding of this new program, the science behind it, the inevitable debates surrounding it, and what it all might mean.
Right, so the headline grabber then. Scientists in the UK are actually preparing to launch outdoor geoengineering experiments. This isn't some small, quiet lab thing, is it?
No, not at all. This initiative has substantial backing. We're talking $50 million in government funding, plus there's an additional $11 million project sort of related to it.
Wow, $50 million.
Yeah, it's a serious commitment. It really positions the UK as, a major global player, or at least funder, in geoengineering research right now.
And the agency steering the ship is ARIA, you mentioned. What's their angle on this?
Yeah, ARA, the Advanced Research and Invention Agency. They're the key governmental supporter here. They've stated pretty clearly that these initial experiments will be small scale.
Okay, small scale.
And subject to rigorous evaluation. That's the message. Their core aim, they say, is to gather what they're calling critical data. Basically, to properly assess the potential of these technologies.
Right, data first.
Professor Mark Symes is heading up the program for ARIA, and we're actually expecting more specific details about the projects they're funding pretty soon, maybe in the next few weeks.
Okay, so a deliberate, data-driven approach, it sounds like. But, for those tuning in who maybe aren't immersed in climate science day to day, can we just break down what geoengineering actually means here?
Sure, absolutely. So, the majority of the geoengineering proposals we're talking about in this context, they fall under the umbrella of solar radiation management, SRM, you'll often hear it called.
SRM, right.
The fundamental idea is simply to limit the amount of sunlight reaching the Earth's surface. Think of it maybe as trying to create a sort of planet-sized parasol.
A planetary parasol. Okay, that's quite an image.
It is, yeah. And it's important to note, these methods primarily target incoming sunlight. That's different from efforts to remove greenhouse gases already in the atmosphere.
Okay. Good distinction.
Yeah, and that difference has pretty big implications for the kinds of climate impacts they can actually address and those they probably can't.
So how would you even, deploy something like that, a planetary parasol?
Well, several methods are being looked at. The article mentions, for example, the idea of releasing clouds of tiny reflective particles way up high in the atmosphere.
Okay.
Or another idea is using seawater sprays to make existing clouds, like over the ocean, brighter so they reflect more sunlight back into space.
Brighter clouds. Interesting.
Yeah. And the potential benefit, and this is really the key driver behind all this research, is the possibility of temporarily lowering global surface temperatures.
Temporarily?
Right. And lessening some of the immediate harms of the climate crisis.
Right.
The hope really is to buy more time. Time to actually achieve those essential deep cuts in carbon emissions that we know we need.
So it's like a temporary fix, almost. An intervention while we sort out the root causes.
That's how proponents often frame it, yeah.
Which makes a certain kind of sense, especially when you consider, the Guardian article points out, the world's less than stellar track record on cutting emissions so far.
In all these record hot years we've been having.
Exactly. The urgency is palpable. But I can already sense the but coming. Highly controversial. Feels like it might be putting it mildly, doesn't it?
You're absolutely right. Geoengineering is incredibly controversial, and frankly, for some very good reasons. The article does remind us that previous plans for outdoor experiments elsewhere have faced huge opposition and were ultimately canceled.
Right.
There are very real anxieties about potential serious, unintended consequences.
Like what specifically? What are the big worries about just reflecting a little bit of sunlight?
Well, one of the major ones is the potential for really significant disruption to crucial weather patterns. Think about monsoons, for instance, which are absolutely vital for food production in many parts of the world. If you start altering the amount of sunlight reaching different parts of the globe, you could inadvertently shift rainfall patterns. That might mean severe droughts in some places, devastating floods in others.
Wow. Okay, that sounds incredibly risky. You're messing with something as fundamental as global rainfall.
Precisely. So while you might be aiming to solve a global problem, warming the methods themselves could potentially create or worsen regional problems, maybe hitting vulnerable populations hardest.
And I imagine there's also that concern, does this weaken the push to actually reduce fossil fuel use, like a moral hazard?
That's absolutely another primary concern. Many scientists worry that if geoengineering starts to look like a viable plan B, it could seriously diminish the urgency to tackle the root cause, burning fossil fuels.
The get out of jail free card temptation.
Sort of, yeah. They argue it's like treating a serious illness by just managing the symptoms, not curing the underlying disease.
Right.
In fact, the article quotes some senior scientists who've called AII's program things like a dangerous distraction and even barking mad.
Barking mad, wow.
Yeah, comparing it to treating cancer with aspirin, those are pretty strong words. There's definitely a fear that even just researching this seriously could subconsciously lessen the public and political will for the hard work of cutting emissions now.
Strong words indeed. But Professor Symes, the guy leading the Aria program, he clearly feels this research is necessary. He highlights the looming threat of climate tipping points. What exactly are those?
Okay, so climate tipping points, they're basically critical thresholds in the Earth's climate system.
Mm-hmm.
If we cross them, they could trigger huge, potentially irreversible changes.
Irreversible.
Yeah, things like the collapse of major ocean currents, like the Atlantic circulation.
Okay.
Or the rapid melting of massive ice sheets in Greenland or Antarctica. Professor Symes is essentially arguing that with the warming we're already seeing and where we're headed, these kinds of catastrophic events are becoming increasingly plausible, maybe even this century.
That's sobering.
It is. And he stresses that a major gap in our understanding right now is a lack of, quote, real-world physical data. He argues that while computer models and lab studies are useful first steps, they just can't capture the full complexity. Although, it's worth noting, climate models have improved dramatically. Their resolution is much higher now, meaning simulations can capture regional weather and localized impacts much better than, say, 20 years ago, which maybe makes research more relevant.
But still not the real thing.
Still not the real thing, exactly. So Aria believes they need to move beyond the lab, do these small outdoor tests to see what actually happens. That's the core rationale.
Okay. And they have said, right, that they won't be releasing toxic substances.
Right.
And there'll be an environmental impact assessment beforehand, consultations with locals.
Yes, they are definitely trying to signal a responsible approach, addressing potential concerns proactively.
Right.
And Aria's own documents, their strategy papers, echo this. They talked about needing carefully considered engineering solutions and the potential for responsible climate and weather control eventually. They acknowledge these abrupt climate shifts are possible and feel current tools to deal with them are, well, lacking.
It's fascinating, though, that Aria's perspective in that future-proofing our climate and weather document you mentioned, it talks about maybe shifting from just reacting to climate change to actively intervening and preventing it.
It is a huge conceptual leap, isn't it?
Yeah. They literally ask, could we develop the capability to intervene plus prevent rather than only react? That's incredibly ambitious.
Hugely ambitious. They see what they call a unique combination of push-pull factors, making it necessary to explore this kind of R&D. They feel it's underexplored, ripe for new talent and ideas. They've even launched a specific program called Exploring Climate Cooling.
Wow.
So the vision is incredibly bold, moving from reaction to potential prevention. But of course, that ambition also highlights the, frankly, unprecedented level of control over the planet systems they're even thinking about, which raises profound questions about who gets to decide what's a better climate, all of that.
Yeah, absolutely. And it sounds like their thinking isn't just limited to spraying aerosols way up high either. You mentioned the ARIA document talks about exploring options beyond just stratospheric aerosol injection and cloud brightening, even civil engineering and land use.
That's right. It suggests a wider scope than maybe the headlines imply. Stratospheric aerosol injection, or SAI.
SAI.
That's the one involving putting tiny reflective particles high up in the stratosphere above where our weather happens. It's probably the most discussed method.
Okay.
But it also carries significant potential risks. Regional climate shifts may be affecting the ozone layer. So the fact that ARIA is explicitly looking beyond just SAI and cloud brightening suggests they're casting a wider net.
What kind of things might that include? Civil engineering for climate?
Well, they're asking these fundamental questions. What options are workable, scalable, ethical? Where do the benefits genuinely outweigh the drawbacks. They're thinking about standards for safe trials,
Yeah.
how to account for local impacts, both community and environment. They even mention land use solutions. And critically, they stress the need for close engagement with governments, policymakers, the public. They recognize that governance is going to be a massive geopolitical issue here.
You'd think so. They even brought up that historical example, didn't they? Mount Tambora erupting in 1815.
Yeah, the year without a summer. They use it as a kind of sobering benchmark for the scale of impact even an unintentional climate intervention can have. A massive volcanic eruption cooled the planet significantly, but also caused widespread crop failures and disruption.
Right. It's a stark reminder.
It is. And ARIA's own internal risk assessment, while they admit the probabilities are often poorly understood, it paints a pretty stark picture of potential tipping points if we hit, say, 3 or 4 degrees Celsius of warming.
Like what? What are the big ones on their list?
They list things like the melt of the West Antarctic ice sheet as an extreme risk, the collapse of the Atlantic meridional overturning circulation, that big ocean current system.
Yeah, the AMO.
That's down as very high risk. Then you've got potential methane release from thawing permafrost, dieback of the Amazon rainforest, even things like the Yellowstone supervolcano. The risks there are maybe lower, but the point is these high-impact events are on their radar.
So against that backdrop, you can sort of see the rationale for at least investigating these more radical options, even if it feels deeply uncomfortable.
That's the argument, yes.
Yeah.
The potential consequences of inaction or insufficient action on emissions are also enormous.
Okay. Now, the article also mentioned another UK research effort, a 10 million early MPEL program by Nerc, the National Environment Research Council. How does that fit in with ARIA's work?
Right, the Nerc program. It was announced separately around the same time. It will also investigate the impacts of solar geoengineering.
Okay.
And this is the crucial difference. Nerc's program will rely entirely on computer modeling, analyzing existing data, and looking at natural analogs.
Natural analogs, like volcanoes.
Exactly. Like studying the climate effects of big volcanic eruptions, or even changes in pollution from shipping lanes. Things that give us real-world clues without doing new experiments. Nerc won't be conducting any new outdoor experiments themselves.
Ah, okay. So ARIA is doing the small physical tests, gathering new real-world data, while Nerc is focused purely on the computer simulations and analyzing what we can learn from past events or existing data.
Precisely. Nerc's stated role is to provide the best possible evidence, the robust evidence base, as they put it, but without advocating for or against geoengineering itself.
Got it. So they're trying to inform the debate through analysis.
Exactly. Using climate models to explore the potential consequences, the uncertainties, the what-ifs of different SRM techniques.
And globally, how much money is actually going into this kind of research? The article mentioned the U.S. has been a leader, but maybe the U.K. is stepping up now.
Yeah, globally, the actual financial investment in specific geoengineering research is still pretty small. Surprisingly small, maybe, compared to overall climate science funding. We're talking low hundreds of millions of dollars worldwide, historically.
Huh, really?
Yeah. The U.S. has definitely been the main funder up to now. But with potential policy shifts there, the UK's new injection of cash, that 50 million plus the 11 million, could genuinely make it the leading financial backer in this specific area, for a while at least.
Interesting. But the experts are still hammering home that point.
Oh, absolutely. Experts like Dr. Pete Irvine, who's quoted, are very clear. Geoengineering is not a substitute for emission cuts. That message comes through loud and clear. It cannot be seen as an alternative.
That seems vital to keep repeating. Now, Professor Jim Haywood, he got one of those Nerc grants, right? He suggests scaling up SRM could be feasible in about a decade. That sounds quite soon.
Yeah, Professor Haywood does suggest the technology could potentially be scaled relatively quickly, maybe within a decade or so. And he argues that...
You think? Yeah.
His project is actually about bringing people together from different regions to try and understand those potential global consequences, the political fallout, the equity issues.
That sounds crucial.
It really is. And interestingly, Dr. Eastham also suggests that one potential outcome of all this UK research, both ARA's and Nerc's, might actually be to help rule out some of the proposed technologies.
Oh, really? Narrow the field.
Yeah, perhaps showing that certain ideas are just too risky or impractical or have unacceptable side effects. That could help focus efforts maybe on areas that seem potentially more helpful and less harmful.
That would be a valuable outcome in itself, wouldn't it? Even if the answer is don't do this.
Absolutely. And ARIA's own documents, again, they really underscore how vital improved simulation and monitoring capabilities are for evaluating any of these options responsibly, they point to those big advances in climate model resolution.
Right, the more detailed models.
Which allow for much more precise research scale experiments, or at least simulations of them. And they even sort of muse about the possibilities,
Yeah.
What could a reliable climate and weather controlled toolkit unlock?
Like what? What are they dreaming of?
Well, they throw out ideas like mitigating severe weather events, stopping Arctic ice melt, maybe even greening deserts.
Greening deserts. Wow. Okay, now we are in sci-fi territory. But hang on, the practicalities of that, the potential downsides, that sounds incredibly complex.
Oh, absolutely. It borders on utopian thinking, but as you say, the potential downsides, the unforeseen consequences, quickly bring you back down to earth. It's this constant tension between potential massive benefits and potentially catastrophic risks.
And Aria themselves use that Tambora example as a reminder of the scale and disruption involved, even unintentionally.
Exactly. And they link it to the current projections, likely exceeding 1.5 degrees C soon, potentially hitting 3 or 4 degrees by 2100. And they note that time lag because the oceans absorb so much heat initially.
Yeah.
The full warming effect takes time to manifest. And going back to that risk register, it underlines the urgency they feel, given those potential high-impact tipping points. They even float ideas about the role of finance. Could there be climate cooling credits?
Interesting.
And they highlight the sheer economic cost of extreme weather events, already floods, wildfires, storms, showing charts of rising costs as a driver for looking into control technologies. They also point to that recent example of reducing sulfur in shipping fuel.
Oh, yeah, the IMO 2020 rule.
Right, an environmental regulation, done for good reasons, air quality. But it had an unintended side effect, slightly increasing global warming because those sulfur particles were actually reflecting a bit of sunlight.
So an accidental geoengineering experiment in reverse.
Kind of, yeah. It illustrates how sensitive the system can be and how our actions have complex climate consequences, sometimes unexpected ones. They use it to show how human activity is intervening, intentionally or not.
Which I guess strengthens their argument for needing to understand intentional interventions better.
That seems to be their logic, yes. Better simulations, better monitoring are key to evaluating options responsibly. They contrast the tiny historical spending on climate engineering research with the huge economic risks of unchecked climate change and the potential gains if control were possible. Their ultimate vision seems to be a trusted toolkit, allowing accurate prediction and proactive management.
Okay, so let's try and summarize this deep dive then. The UK is launching significant government-backed outdoor geoengineering experiments via Aria, focusing on getting real-world data.
Right, driven by concerns about climate tipping points and feeling that models alone aren't enough.
But it's hugely controversial. Major concerns about unintended consequences like shifting rainfall, and the big one, undermining efforts to cut emissions at the source.
Definitely. Plus, there's complementary research from Nerc using models and existing data, not outdoor tests, to provide evidence without advocacy.
And globally, the funding's still quite small, but the UK is now a major player, potentially the major player. But there's no international governance for any of this yet.
Correct. And Aria's broader vision involves exploring a range of interventions, potentially moving towards active climate control, underpinned by better modeling, but raising massive ethical and geopolitical questions.
So the core insight here, the aha moment for you, our listener, is probably grappling with the sheer complexity and the incredibly high stakes, wouldn't you say?
I think so, yeah. It's this stark contrast, potentially huge benefits versus potentially catastrophic risks and unknowns, all wrapped up in these really profound ethical dilemmas. So how should you think about this? Is it hope? Is it fear? Is it just complicated?
And for you, listening, who wanted to get a solid handle on this complex topic quickly but thoroughly, we hope this deep dive has laid that foundation. If you want to dig deeper yourself, keywords like geoengineering, solar radiation management, SRM, climate tipping points, Aria, and Nerc, NERC will definitely open up more information for you.
Which leads us, I suppose, to a final thought for you to chew on. Given the undeniable scale and urgency of the climate crisis we face, but also the really significant uncertainties and risks surrounding geoengineering, what do you think is the most responsible path forward for humanity now?